Hello, my name is Arne Smets. I'm professor in photovoltaics, materials and devices group at TU Delft. Welcome to the third course in our MicroMaster series Solar Energy Engineering. This third course is called Photovoltaic Systems. In this course you will learn about all the aspects involved in the design of a variety of photovoltaic systems. This course can be followed as a standalone course. If you are interested in the physics, engineering and processing of solar cells, I advise you to follow the PV1X Photovoltaic Energy Conversion or the PV2X Photovoltaic Technology courses. For this course, the lectures will be Associate Professor Orlindo Isabella and Dr. Ravi Vasudevan, both working in the Photovoltaic Materials and Devices group at the Delft University of Technology. Our group has expertise in teaching and research in all aspects of photovoltaics, from fundamentals to device fabrication and full system design. The course Photovoltaic Systems is split into 5 parts. The first part will serve as a short introduction. In the second part, which takes place in week 2, we discuss all issues involved with the location of a PV system. The third part, which consists of 2 weeks, we look into the PV module. In part 4, which takes another 2 weeks, we consider all the necessary balance of system components required to make a PV system. Finally, in part 5, we will apply the knowledge of all preceding weeks to design and integrate a PV system. Let's go through all of these 5 sections in a bit more detail. The first week is a short introduction into PV system design. This week contains only a few videos. This gives you the time to get familiar with the system design assignments, on which later more. In week 2 we discussed the location issues. First we will discuss solar irradiance and the different components of irradiance on Earth. You will learn to define the position of the sun in the sky. We will use that to calculate the optimal tilt angle and orientation for solar modules for any position on Earth. At the end of week 2, we will discuss landscape survey, where you learn to predict the influence of surrounding area on the annual PV system performance. Finally, you will be introduced to some advanced irradiance modeling techniques. In week 3 and 4 of the course, we will discuss PV modules. In PV1X and PV2X, we discuss the operation principle of solar cells and many different PV technologies. In this section, you will learn how multiple solar cells are used to make a PV module. We will look at the different interconnection techniques and at the design concepts of the metal contacts of modules. You will learn all about the operation of PV modules. What happens to the current and voltage of a module when a single cell is shaded? Why do we include diodes in the module? How many diodes should be included? We will also look into the performance of a PV module under increased temperature and irradiance. Finally, we will discuss how temperature, partial shading and moisture affect the reliability of PV modules and how this is tested. Solar modules alone are not enough to make a PV system. In part 4 of the course, we'll look at all the balance of systems components required to design a PV system. We will discuss in detail the operation of DC-DC converters, DC-AC inverters, energy storage units like batteries, charge controllers and even the cables and mounting frames. You will also learn about maximum power point tracking logic that is usually contained in one of the balance of system components. In the final part of the course, you will learn all the skills required to design a PV system. PV system design often starts with an analysis of the loads that need to be powered. Load analysis is important to determine the size of your PV system. We will provide you with the skills to design a PV system of any size and type, ranging from rural standalone and local grid system to grid connected and building integrated system, all the way up to complete power plants. The final section of this course will focus on the integration of PV systems. You will learn about the issues related to integrating PV systems in the existing power grid. And finally, some financial aspects of PV will be discussed. We recommend following along in this course with our textbooks, Solar Energy, Physics and Engineering of Photovoltaic Conversion Technologies and System. This textbook is available as a free ebook for any e-reader on Amazon. Hard copies are also available for purchase at Amazon.com as well as other retailers. All the video content in this course, as well as numerous ungraded practice assignments, are available for free. These exercises are meant to test and improve your understanding of the concept discussed in the videos. So try exercises and don't be afraid to make a mistake. By upgrading to the verified learning experience, you will get access to all exercises, the practice and graded assignments and exam questions. In this course, we use a web-based version of MATLAB to run and assess the system design assignments. In the Getting Started week, you will find some MATLAB tutorials to help you get started. However, please note that the design assignments are about transferring skills, not MATLAB code. When designing your own PV system, you can use whatever computational software has your preference. Each week will have one system design assignment, which in total counts for 10% towards your final grade. All the weekly graded assignments combined count for 30% towards your final grade. There are a total of 3 exams in the course which count for 60% towards your final grade. You can qualify for the PV3X verified certificate by achieving a minimum final score of 60%. Besides the regular content, PV3X also features a live webinar in which you can interact live with the course team. The webinar generally includes a behind-the-scenes tour at the TU Delft, an interview with a titan of industry, and an interactive discussion in which the course team treats the issues introduced by students. You can submit your solar energy related questions a couple of weeks in advance. Look for more information in the webinar tab of the Getting Started week. On behalf of the entire Photovoltaics Materials and Devices team here at Delft University of Technology, I'm very excited to provide this course for you. I hope you are ready to dive right into all the different aspects involved in the design of PV systems.